All right, so let's try to solve this system of equations. I mean, sometimes I may give you the equation in this form, sometimes I might spell it out. What does that really mean? It means x prime is 7x minus 4y, then y prime is 5x minus 2y. That's what it means. So you have to know how to go back and forth. I might give you this and say, oh, what system is this? Write it explicitly. You have to write it like this. I might give you this and say, write it in matrix form, then you have to be able to write it like this. Okay? That matrix is the coefficient matrix, 5, 7, -4, 5, -2 of these numbers. Okay, how do you solve the system? So you're told to first think about the determinant of lambda subtracted from the diagonal. This is called the characteristic equation. And the determinant is computed by this way, the AD minus BC. So it's 7 minus lambda times -2 minus lambda minus -4 times 5. That's lambda squared minus 5 lambda minus 14. And this one is plus 20. So you get lambda squared minus 5 lambda plus 6. And then you have to know when this becomes 0. So the question is, when does this become 0? This factors as lambda minus 3, lambda minus 2. So lambda equals to 2 and 3. Those are the two eigenvalues. Okay, once you find these eigenvalues, next step, this you can call it as step 1. Next step is to find the eigenvectors. Eigenvectors is, there are two ways to look at eigenvectors. One is to say eigenvectors are something that if you multiply 7, -4, 5, -2 to this eigenvector, it's same as AB with a constant multiple. That's what eigenvalues mean, but equivalently you can rewrite this as you can subtract the lambda off the diagonal. Not equal. It's the same as saying so algebraically those two are the same thing. The reason that they are same is that you can just check it out. You can just multiply the matrices and you can check that if you do this times that equals lambda times A, you get exactly the same thing as doing this times this equal to 0. And because the second one is easier to compute, from now on, you're always going to try to find the eigenvectors in this format. Okay? So to repeat myself, I'm saying if you're given a system, first come up with the matrix of coefficients, subtract lambda off the diagonal, take the determinant, set equal to 0, that gives you the eigenvalues. Once you find the eigenvalues, then you solve this eigenvector equation, which is you take the same matrix as you used to find the eigenvalues, multiply A comma B, and set equal to 0. Okay? For each individual case. So for lambda equals to 2, what does this mean? Lambda equals to 2 means you get 7 minus 2 is 5, -4, 5 and -4. And I talked about how the second line doesn't do anything. Another way to say it is that this matrix is the degenerate matrix. If you take the determinant, it's 0. 0 determinant means it doesn't have a inverse, and that's what enables you to find a non-zero solution for AB. Okay? So you're looking for a non-zero solution of this equation, and you're only going to read the first line, which is across down. It's 5 times A minus 4B equal to 0. And because this is just a single equation with 2 unknowns, there are actually infinitely many solutions that satisfy this. You only need to find one. What satisfies this? Usually if you switch these values around, it works, right? You take 4 and put it here, 5 and put it here. Sometimes you'll have to change the signs. This time it just works. 5 times 4 is 20. 4 times 5 is 20. 20 minus 20 is 0. So I guess if you take A to be 4 and B to be 5, that's an eigenvector. Okay? Let's do the same thing for lambda equals to 3. This time 7 minus 3 is 4, negative 4. And then 5, this one will be negative 5. AB equal to 0.
Why is it a negative? Oh, wait, no.
Yeah. And then if you read the first line, that's 4A minus 4B equal to 0. And this time I can just divide by 4 to get A minus B equal to 0. So dividing by 4 gives you 4A divided by 4 gives you A, 4B divided by 4 gives you B. And it just means A and B has to be equal, so I take 1, 1 as the eigenvector. All right, from these two, now what's the final solution? The final solution is that xy is, you take C1 of the eigenvector. Can I have extra space here or there? More?
Right there.
Okay, all right. So C1, 4, 5, and then E to the eigenvalue, which is 2t, plus C2, and then you have 1, 1 is the next eigenvector, and the eigenvalue for this eigenvector is is 3. So that, there you go. That's the solution to the differential equation. Now, sometimes if you are given the equation in this form, you might be requested to find what x is, what y is separately. Okay? So if the question was, what's y of t, how would you answer? Y of t is c1 times 5 e to the 2t plus c2 times 1 times e to the 3t. That's how you can write it. Okay? So this can be written as x and y. What's x? X is 4c1 e to the 2t plus 1c2, which is a c2 e to the 3t. Whereas y is equal to 5c1 e to the 2t plus 1c2 e to the 3t. So if you take these, and if you want to check, if we have the time, we can actually plug these into the left side and compare with the right side, and you'll see that they're equal. And these two do satisfy the system.